You understood the process, right? How to install this Jupyter?
Yes, yes.
Okay. So if you face any issues, just ping me. We can connect at that point
Okay.
while installation. So I just started the recording. Okay, fine. So we'll move ahead with this. So we were discussing these comments in Python. So how to comment the single line comments or multi-line comments. So we'll look at that here. See, this is single line comment. Just put hash. Just put hash over here. That is single line comment. If multiple statements are there, again you have to put hash only. Okay. So so statement by statement, line by line, we can comment here. Or else, if you want to uh, comment all the statements at one go, we have to just select the statements and press control control and question mark key. You understood what I press? I press control key, control and question mark simultaneously. You got right?
Yes, sir.
Yes, sir.
Now what is docstring? Docstring also used to comment the statements, the block of statements. Okay, but basically docstring is used inside the functions. Now what is function? You might know or may not know, but we'll discuss that at later point. But inside the function, uh, we are describing that function inside the function body, and that description we are commenting. We don't want that interpreter should look at that and execute that, and that's why we are commenting that inside the function. So docstring can be used like this. Let's say there are multiple statements here, and I don't want interpreter should execute all the statements. So what I do here is I just put this thing, triple quotes. Okay, and I will put this block of statements inside this. Okay, so whatever written here would be ignored by interpreter. This would not be executed. Oh, what happened? Wait, let me write one function. Let's see. Okay. So basically, this we have to put this inside the function, so not outside. So probably as a single statement, it was giving some errors. Mm, okay, fine. Now I'll call this function from here. Okay, fine. Okay. So docstring is again used to comment the block of statements, but this block of statements are inside the function. You understood, right?
Yes, sir.
Yes, sir.
You cannot put this outside the function. See, if I moment I move this outside the function, it will complain. Oh, no, it's executing. But the thing is, docstring is basically used for commenting the statements or whatever written function description is written inside the function body. Okay, so outside the function, we basically use the hash only. Okay, this is a good practice for writing while writing a code in Python. So this was about the comments in Python. So we'll move ahead with the data types. Yesterday we saw some basic data types like int, float, and little bit string, right? So today we'll see more. Uh, there are several data types in Python, like none. Okay, none is one of the data type. Means none means nothing, null value. Nothing is there in that object. Okay, numeric data type. So inside numeric we have int, float, and complex data type. Then we have bool data type. We have sequences. We have sets. Okay. Under sequences, we have string data type, bytes, byte array, list, tuple, and range. Okay. So we will be seeing all these things in detail at later point of time while writing some programs. Okay. So we'll soon see some examples in this programmatically. Okay. I'm storing this. I'm storing this none in this variable a and trying to print value of t. So it is printing this in. Can I add this value? Likewise, if I have a equal to 10 and b equal to 20, I can add these two variables, right? If I take some integer variable here and can I add this? Let's check. I need to execute this. No, right? Why? Can you
Non
think?
type.
Can you think on this?
You already assigned that variable as non type.
None. So
Hmm.
it means null value. So we
Yes.
cannot add this null to the integer value. Okay. Let's say if I have some string here, can I add this? So thing here is if there is a none type, we cannot append this with the string or anything. I mean, we cannot add this to the another type, right? So none
Yes,
means
sir.
none. Nothing is there. Let's look at string data type. In other languages like C and Java, we have some character type of data type. We don't have uh, that data type over here. We have str. Str is basically that is a collection of characters. This is basically string. String is a collection of characters. Let's say if I define one variable str and put some assign some string over here and try to print, so it will print this. I can use this as an array. What is array? We will look at this that at later point. Okay, so I can get any character, extract any character from this string. How? Str of 0. So I want h. So it is returning the zeroth character. So this was about the string variable. We will look at some more programs in the string, some operations on the string data type, like slicing and all. Okay. So for now, so this is sufficient for now. So we can create we can declare a variable and assign the value, string value to that variable. String is actually that is part of sequences, right? So okay, it doesn't matter. So now we'll look at the numeric types. Yesterday we saw this int, float, and right. So we did not see this complex type. So we'll look at this now. Yes, sorry. Let's say C1 equal to you know complex number, right? This is of this form.
Yes.
A plus B, A plus imaginary number. So A plus B and
Mm.
appending one J over there. So I'll just assign
J
some
is
value.
imaginary.
I will just assign some value, complex number over here. Let's say 3.6 plus 2.8 J. C2 equal to 0.9 plus 1.2 J. Now I will add this and store the result in C. C equal to C1, C2. Okay, so it has added this real number first, okay, and imaginary number. So if we check the type of this C, it should return the C complex
Type.
type of C. There is another data type called bool. Bool means boolean type. That is either true or false. Let's say a equal to 10. b equal to 20, I'm just printing a greater than 20. I am saying a greater than 20. This is one condition. Okay, sorry, a greater than b. Okay, so it should return false. Sorry, a equal b, a less than equal to b, it should return true. So this is boolean type. So if I want to assign some boolean values and I can make use of those values, I can do that. Like flag equal to false. Okay, flag equal to false. If you check the type of this flag, it should return bool. Okay, got it.
Yes, sir.
Yes, sir.
So next is the sequences. As I said, str is a part of sequences because it's just when we are declaring one variable and assigning some string to that variable, that becomes a sequence of characters. Okay, or collection of characters. So next is a bytes. Bytes is nothing but a array. Again, array. It's an array of bytes between 0 to 255. Okay, let's create a byte array. See this these bytes and byte array both are same. So we will look at the difference. What is the difference between them? Let's check the type of B. What is B? It is a list. It's not a bytes. So what we will do? We'll explicitly convert it into bytes. Something went wrong. So probably it's not allowing us to print the whole byte array. Instead of doing that, we can get the each element out of that. Extract element out of this byte array. We'll try doing that. Print converted bytes of say 3. Yes, you got right. We can print the whole list, but once it is converted into bytes, it is not allowing us to print the whole byte array. So instead of rather than doing that, we are just picking out uh, each element out of that. we can do that. You understood this bytes data type?
Yes,
Yes,
sir.
sir.
Okay. So the next data type is a byte array. Again, we will do the same thing. We'll define the array likewise, like as like earlier. So now again, this is a list. Okay, we need to convert it into byte array. Again, if we try to print this thing, it should show us in the byte form. But the type should be displayed as byte array. Okay. So now we can extract the element as like earlier, means what we did in byte types, byte data types. We can do that here as well. Okay. Now what is the difference? Both are functioning the same, but then what is the difference between byte data type and byte array data type? Let me try uh, updating any element in byte data type. Okay. What is the byte data type? Converted bytes. Okay. So what is the zero element? Zeroth element 20. So let me change it to 10. So bytes object doesn't support item assignment. You cannot assign or you cannot change any value inside the byte array. Same thing we'll try with byte array. Now we'll print this. Sorry, zeroth element. See, so this is the difference between byte data type and byte array data type. You got the difference, right?
Yes, sir.
Yes, sir.
So what next? List, tuple, and range. Okay. So first we'll look at list. List again it's same like array only, but the difference is we can put n number of sorry, any type of elements inside the list. Any type of list. Well, if I create a byte array, if it is a byte array, or if it is a byte data type array, it's an integer. If it is integer array, I can put only integers inside that. I cannot put strings in that array. So if I want different types of elements in some in collection, so I have to use list. We'll do more programming for list when we uh, when we look at loops. Okay. So for now, we'll this is sufficient for now. So we'll move ahead with tuples and range. Tuple, it is same like list. Okay, you can put any type of element inside this tuple, but the declaration is different. So how we are doing that? Here we are using this parenthesis. Here we are using square brackets. Okay. Okay. So if it is same like list, then what is the difference? You will ask what is the difference? Okay. So only this is a difference. Just how we are forming that? No. So difference is tuple is immutable. Okay. We cannot change any element inside the tuple. How to access that? In both list and tuple, we can access this. Access the element like this. Okay. Now try changing this. Try updating this value. So tuple is not allowing us to update the value, update the elements inside that. Okay. But same thing we are doing with the list. It will allow us. See what was the first element? Zeroth element in list 19. It's showing at 30. So this is the difference between tuple and list. Next is range. So range is basically used for let's say numbers in the sequence. Okay, let's say 1 to 10. So I want to iterate through all the numbers between 50 and 100. So what I'll do, I'll just create a range. Okay, likewise, a equal to range is basically declared like this. Okay. you can use range function here, range of 10. So it will now actually start with the 0. So this is basically loop. So we will see that later. You understood this
Yes,
range
sir.
thing?
Yes,
Okay.
sir.
Let me try with this 10 to 20. There should be something. No, it's not starting from 10. Okay, I'll check this. Let you know later. Okay, we will move ahead with sets. Sets data type. Okay, sets basically we can declare the sets like this. Sets, you know the sets in mathematics, right? So it is
Yes.
same like that set.
Yes, sir.
Sets are actually declared like in this curly braces. Okay. So we cannot extract the element like or as we do in list, not susceptible. Okay, so we need to take loop only over here. Or we can print the whole set over here likewise. See, your problem is it's not necessary it will maintain the sequence over here. What sequence you have put, what sequence the numbers you have put over here, it will not maintain the same sequence while printing the output. Okay, look at these values. Okay, can you tell me what I did here now, just now? Did
Add
I
a
put in some?
duplicate value.
Yeah, I added some duplicate values, but still it is showing the same values as earlier. Why?
Yes.
Because set is taking only unique values. Whatever you put, how many duplicate values would be there? It will ignore those duplicate values and just pick up the unique values. Okay, so this is the difference between sets and list. List, in list you can have duplicate values. but in sets you cannot. Okay, any question in this data types?
No, sir.
No, sir.
Okay, so we will move ahead with the operators, basic operators. So what are the operators in Python? What operators are being used in the Python? First thing, operators are symbols that perform an operation. Okay, operation on any operands. Operator operates on a variable, which is called an operand. Again, there are multiple types of operators are there, like arithmetic operators are there, assignment operators, relational, logical. So arithmetic operators are used to perform some operations like addition, subtraction, multiplication, division, modulo operation, and exponentiation. Okay. Assignment operators are used to assign the values to the variables. Relational operators are used for comparing two objects. Okay. And then logical operators are used to check the conditions and it will return some true false value. Again, there are some membership operators uh, to check if values are present in the set, okay, or set or list or in any kind of array. Again, there are some identity operators like is and is not. These operators are basically used to compare the identity of the two objects, whether the two objects are identical. Okay, see this identical and equal. There is some difference between these things. When we say equal, means it is comparing the values of two objects, and when we are saying identical, it is checking the memory location of those objects. And in order to check the memory location, we are using this is and is not operator. Okay.
Okay, sir.
See, for example, arithmetic operators. So these are the examples. Assignment operators, then relational, less than, equal to, greater than, equal to, equal, not equal, logical operators, and, or, and not, in and not in operators, and is and is not. These are the membership operators, and these are the identity operators. The last one. Okay. So we will look at some small programs for all these operators. I think yesterday we saw some small programs for arithmetic operators, right? Plus, minus, modulo we did not look at, and modulo and this exponential.
Hmm.
Okay. So I will do some division, and I want a reminder to be shown in the on the console. So for this, I will just use modulo operator. So it should return 2 over here. Okay. Now we will use the exponential. Say A equal to 8. I want square of this A. So what I'll do? So by 8 or A into 2. So rather than doing A into A, what I'm doing here is okay. Now I want cube. I just change this over here. Okay. Assignment operators equal to we saw, plus equal to minus equal to, these operators we did not see yet. A equal to 20. So here we are assigning this 20 to A. Then we are adding 10 into this A. Same thing, same thing can be achieved using assignment operator plus equal. A into equal to 2. So it should return now 60. Okay. A division operator equal to 2. It should again return 30. Okay. Any question?
No, sir.
Any question about this output? Hmm? Did you notice that we had on integers, we divided one integer by another, but still we got this value as type float. But in Python, when we divide any two integers, we always get back floating type number. Okay, it's not
Okay.
guaranteed that we will get some integers. If we want integer, we need to typecast that. We have to explicitly convert that into integer. Okay. Understood?
Yes, sir.
Okay. So next, relational operators: less than, greater than, less than, equal to, greater than, equal to, equal, equivalent, not equal. So this, when we use these operators, we will always get back a boolean type of value. Okay, we will always check the condition, some conditions. If a is less than b, or a is greater than b, a is less than, equal to b. Okay, print x greater than y. So this is returning false. If I say x equal y, again returning false. X greater than, equal to y,
True.
again it is returning false. And if x less than, equal to y, it is returning true.
Mm.
If I say x not equal to y, then also it should return true. You got right.
Yes, sir.
These are
Yes, sir.
relational operators.
Mm.
Next, logical operators: and, or, and not. These operators basically called as conditional operators. Uh, they are basically used to combine two conditions. Let's say I want two conditions, and I want to perform some operation on the basis of uh, true or false of these conditions. If it is true, if both the conditions are true, then only I want to perform some operations. Okay. So what I'll say, condition, if condition one and condition one and condition two, and means what? In order to perform the rest of the things, whatever written over here, in order to perform all these things, I want this both these condition to be true. Okay. So and means both should be true.
Mm.
If I put or any of these, either of these true, then operations would be performed. Okay. If I put both the conditions false over here, so it won't execute these statements. And if I put and any of the statement, any of the condition is uh, false, then in that case, the subsequent statements won't be executed. Okay. So this is a and. Let's say I say here print x equal y and x less than y. What it should print? False, because this condition is not true. Okay. X is less than y, but this condition is false. Same thing, if I put or here, it should return true.
Mm.
Not means negation of something. Let's say I define one variable here, boolean type variable here. Let's say flag equal to true, and if I print not black, it should return false. See, in and not in. Let's say we have one list of say let's say names. So I want to search this name in this list. So what I will do is just put a statement like if name to check in names. So print. So what it will do, it will check this name inside this list. If it finds over there, it will return true. Otherwise, false. False. Okay, so got it. This
Yes, sir.
Yes,
in
sir.
operator.
Yes,
How it
sir.
is not in operator? Just negation of that. Print not
Not
in
in.
names. Now, since Divya is present there in this list, this statement should return false. This would return true, and this will return false. Now let us look at the last operator. That is uh, is and is not. What it should print? N1 equal n2 true, right? But when I say n1 is n2, let us see what happens. It's saying false. Why? Because see, when we declare any variable, some uh, some location is allocated for that variable in the memory, right? Okay, some location. That location has some address. Okay, so when I declare variable n1, it gets some address in the memory. When I declare another variable, say n2, it will get another address. And when we use this is operator to check these two objects whether these objects are identical or not, what it's doing, it's just checking the location address of these objects. Now since it is different, it is saying they are not identical. False. Okay, you understood this concept?
yes,
No,
Okay.
sir.
Now
No.
see, when we are saying equal, at that time it's checking, interpreter is checking, Python is checking the values inside that object. values stored inside that object. And now since it is checking the values, okay, it is saying true. So these two are same. Okay. So on the basis of this operator, equal operator, it is saying both these objects are same. But the moment I change this equal to is, now I want to see whether these objects are identical. Identical means same at located at the same location. So when we declare any object, what Python will do, it will allocate some space in the memory, and that space or that location has some address, right?
Yes.
So address that would be some hexadecimal number. Okay. So what Python does when we use is operator, it would check for that location address. Now it is obvious that N1 and N2 are two different objects. It would have some different address. Correct?
Mm.
So now since it is checking for the addresses of these objects, it is saying they are not identical and it's returning false.
Okay.
If I say N1 is not N2, that's true. It's returning true. But if I say N1 not equal to N2, now this is false statement, right? N1
Yes.
not equal to N2 because the values are same. So it should return false, right? You got this?
Yes, sir.
I'll do some different thing here. I'll declare one more variable, say N3, and I'll just assign N1 to this N3. Okay. Now, if I say N1 equal N3, it should return true. Again, if I say N1 is N3, then also it should return. Now, why this is happening? When we assign any object that has been already declared to the new object, what happens in the memory is some reference is created for that object. One reference is created for this object, and now what is happening? This object is referring to address location of this object, and that's why it is saying that if when we say n1 is n3, it is saying true because it is referring to the address of this location. You understood this?
Yes,
Yes.
sir.
But when we say moment we say n1 equal to n2 or uh, n2 is n3, n2 is n3, it is saying no. These are not identical. False. You got this right?
Yes, sir.
Any query so far? Data types or operators? So we have almost covered all the operators, data types in today's session. Any query? Ask the
No,
question.
sir.
No, sir.
Anything about tuple you not understood, tuple or string or list? Okay, fine. So today we'll stop here, and we have covered all the basic things like data types, variables, operators. So from tomorrow onwards, we'll look at some programming concepts like control statements like if statement and then loops. Okay.
For
Huh?
nothing, sir.
Okay. Okay, fine. So today we'll stop here. I'll share this recording on the Google Drive. Okay, I'll place it over there and just we'll check with Abhijit. He would be sharing that location with you. Okay.
Okay, sir.
Okay, sir.
Okay then. Bye.
Bye, sir.
Bye, sir.
Thank you.